Hello, today's lesson that we are going to look at is 8.1 sequences and series. So the first thing that we need to know is what is a sequence? So a sequence is really just a list of numbers. And you can have two different types of sequences. One's called infinite, meaning it goes on forever. And one's called a finite. So it has a set number of values. So when they talk about this, they use subscripts. So they say like A1, A2, A3, all the way through AN. And N could be any integer. It could go on however long you want it to. So when we talk about terms of a sequence, A1 is the first term. So what they will do is when you're trying to find A sub 1, you're going to plug in 1 for any n. So in this case, we'd have 3 plus a negative 1 to the first power, which is going to give me my first number of my sequence is 2. So it's asking for my first 4. So I would also need A2, A3, and A4. So A2 would be 3 plus negative 1 squared, which is going to give me a 4. Then I would continue on by plugging in 3. So I'd have negative 1 to the third, which that's going to give me a 2. And what you'll notice is this is a different kind of sequence that is going to kind of rotate. So then the next one, when I do to the fourth, is going to give me a 4. So those would be the first 4 terms of my sequence. So a sequence, you can't just list the first few terms. That's not a significant amount, and it's not sufficient to define a unique sequence. You need the nth term. So you need something that would say an equals 3 to the n, or some kind of equation to be able to denote a specific sequence. Now, there are 2 ways to denote sequences. One is like what we just did, and that's considered an explicit sequence. We also have what's called recursive, and recursive is based on a previous term. So it could say an plus 1 is equal to an plus 3. So it would be the previous term plus 3. So there's different ways to define sequences. The next thing that we need to look at is factorial notation. So when you're talking about a factorial, that's this exclamation point. So when we have n factorial, notice it's 1 times 2 times 3 times 4, all the way up to n. So if I said 4 factorial, that would be 1 times 2 times 3 times 4. The number there tells you where to stop, and then you would multiply all of those together. Many calculators also have a factorial button, so you'll see an exclamation point on a calculator, and that doesn't mean that you are just exclaiming something. That means factorial. So it's the 1 times 2 times 3 times 4. A special case, 0 factorial is equivalent to 1. Summation notation, really you're taking a list of numbers and you're adding them together. So this Greek letter sigma here just means add up all of these terms in this sequence. So they talk about it in terms of the index, the I down at the bottom. Sometimes it's I, sometimes they use N or K. It doesn't matter. So you're going to, that I equals 1, that tells you where to start. The N on the top is going to tell you where to stop. So you're going to plug in every integer between the number on the bottom and the number on the top. So when we talk about summation, so if you're looking at the first one here, they're talking about the sum of the first through the 5th term. So in this case, we're going to take 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. And we're going to calculate all of these. So we'd have 3 plus 6 plus 9 plus 12 and plus 15. And we're going to add them all together. And that's going to give me a 45. Now, the same thing on the bottom, but you're going to start at the number 3 and you're going to end at the number 6. So you'd have 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared. And you can type that in the calculator and find what that sum is equivalent to. Properties of sums. So these are just different ones that you probably should know. If C is a constant, if it's just a number, and you're adding that number for a set number of times, which is what this is saying. It's like adding, say 1 to 3. So you would be adding, and if C was a 5, 5 plus 5 plus 5, which is really C times N. So if you notice here, You could pull the constant out front also and do that summation and then multiply by the constant. You can also split the two things apart. So they split the a sub I and the b sub I apart with addition or with subtraction. So those are some different properties of summation. Well, that leads us into series. So a lot of times sequences and series go together. Sequence is just a list of numbers, whereas series is the sum of the list of numbers. And you can do a sum of what's called a finite series or sum of an infinite series. Okay, infinite series meaning it goes on forever. I hope this gives you a good start for this lesson for this week. If you have any questions, please don't hesitate to send me an email. Have a great day.